Hello, my name is Zaur, and I'm the leader and also first engineer of the team for the 6. And in this video, we are going to present the process of making 3 gates. First is not, the second is and the third is or.
Hi, my name is Tofig. I am the video editor of the team.
Hey everyone, my name is Oruj. I am second engineer of this team.
Hi, my name is Yusif and I am the videographer of the team.
First, we constructed a NOT gate. We started by placing a battery on a solderless breadboard to serve as the power source. Then, we added a push button, which acted as the input for the circuit and connected it to the positive side of the battery, since electric current flows from positive to negative. Next, we connected a 2000 ohm resistor to the push button, and this resistor was linked to the base of the transistor. The collector of the transistor was connected to a 330 ohm resistor, which was also connected to the positive side of the breadboard. An LED light was added as the output and connected to the negative side, completing the circuit. The emitter of the transistor was also connected to the negative side of the breadboard. At first, we noticed that the circuit didn't work properly because the left and right sides of the breadboard were not connected. After connecting them correctly, the circuit functioned as expected. When the button was pressed, the LED turned on. When the button was released, the LED turned on. This behavior shows the function of a NOT gate, where the output is the opposite of the input.
Next, we constructed an AND gate. We began by placing a battery on the solderless breadboard as the power source, then replaced the first transistor on the breadboard and connected it to the negative side through a wire. A 2000 ohm resistor was connected to the middle leg of this transistor, its meaning base. From there, a wire connected the emitter of the first transistor to the base of the second transistor, creating a series connection. This setup is what makes it an AND gate, because both transistors must conduct for the current to pass through. The second transistor was also connected to a 2000 ohm resistor, which was then linked to another 2000 ohm resistor connected directly to the positive side of the breadboard. And we added a third transistor connected through 3 wires on the one to 2000 resistor, one to a 330 ohm resistor, and one to the negative side. Finally, we placed an LED light as the output connected through the 330 ohm resistor and ending at the negative side of the breadboard. At first, the circuit didn't work because we forgot to connect a wire to the right side of the breadboard, which stopped the current flow. After fixing that, the AND gate worked correctly. The LED turned on only when both push button were pressed. If one or both button were not pressed, the LED stayed off. This demonstrates the function of an AND gate, where the output is on only when both inputs are active.
After successfully constructing the AND gate, I made a few small changes to create our gate. The structure looks similar, but the key difference is in the how transistors are connected. In the AND gate, the transistors were connected in a series, making a current could only pass when both inputs were active. So LED turned on only if both inputs were pressed. For the OR gate, I modified the wiring by connecting the transistors in parallel instead of series. This allowed the electric current to flow through either one of the transistors. Because of change, the LED lights up when at least one of the buttons is pressed. In the short, I kept most of components the same: the battery, transistor, and LED and resistor, but just rearrange the connections so that current has 2 separate paths instead of 1.